Yo, yo, yo. Sorry about the long delay for the start. I just needed to get ready for this new week. And good morning, Cooler SK. How are you doing today? So, last week I think we pretty much finished the apparel system, or it's like it's in a very good state now. The improvements will be small and incremental. So I think I'm gonna pause with the apparel system now, and I want to do something like, after banging my head against it for as long as we actually did, I want to do something fun this week. So I want to try and finish my procedural grass implementation. So I think it would be pretty cool. A great week ahead. Oh, nice. Same here, I hope. And good morning, Harukanan. I'm a kid at heart. That's all I can say. So, okay, we have the one in the game. That's for sure. So I say unfortunately now, because I would have loved to have the whole process of the procedural grass done in my streams, but I think about 6 months ago I started doing it. I had some time, so I just started a little bit with a procedural grass shader following some tutorial. So we already have a tiny base in place. So the first step now is to just figure out how much we have in place and what the implementation actually does. And I want to solve this, like, I really want to. I've never done any procedural, I haven't done any geometry shader or tessellation shader and stuff like that. So I really want to learn this from the ground up. So even though I have an extremely good tutorial to fall back on here, I'm gonna hold off on that one, because I wanna learn this, because I have some other things planned concerning geometry and like geometry and tessellation shaders in mind. So just wanted to put that out there. What's up, BCG Performance? I'm pretty good. I'm starting to wake up, starting to get energy again. And pretty excited for doing some grass shaders. How about you? So, as I mentioned, I already started procedural grass here, unfortunately. So, I just want to see if it works right now and how it looks in its current state. I'm sick a bit, but I'm good. Bad, but still nice to hear, I guess. Hope you feel better soon. So what do we have? Do I have a material with this one? Environment materials. Here we do have procedural grass. Let's take a look at how like the current state of it. I wonder if I want to use plain 8x8. Maybe this one is good. Let's see here. Okay, we have the bed here. Let's create an empty again and call it furniture. What plane is this, by the way? Oh, yeah. no idea why I'm getting this low frame rate, but let's hope nothing else happens with it. Okay, so let's see. Is something up with my... Okay, this is worrisome. Extremely slow. Let me take a look at that one. It's like something is taking up most of my memory. I wonder what? Let me restart Unity and see if we can resolve it. Good morning, KJJ. How are you doing today? Extremely weird. Okay, it feels much quicker now, so maybe it should fix. Pretty good, except for my head hurts a bit. Oh, hopefully that will be better soon. Okay, let's see if we can continue this without any other... I mean, it feels just... It's just extremely slow. What the fuck is going on? Okay, let's see here. Okay, so I think this is a good starting point for the procedural grass. Let's see how it currently looks. So plane 8-8, let's see. Okay, we have something like this. So this is where what we're gonna start with. Grass bottom color, grass top color, grass bend. I guess grass bend variation. Grass width. We have random rotation as well. That's a good start. Grass height, grass variation. Okay, should probably not go below 0, I don't think. Let's just keep it like this. Okay, so that's a pretty good starting point. So let's see what actually happens in the shader. So first of all, I have util math and util random. Util random is just pseudo-random float given a seed. I thought I had a reference here, might want to add that one. And then we have some math functions, currently just pi and a function that takes an angle and an axis and rotates around that axis by angle. Okay, so these two, together with those two, we have procedural grass. So let's take a look here. Our properties, opaque universal pipeline, forward lit, cool off, makes sense. And then we have a lot of these. I wonder if, yeah. Okay, so the input to the vertex shader is position in object space, normal in object space, tangent in object space. And what do we actually do in the vertex shader? Create variance out, which is the output here. Actually, let's do some renaming. Okay, so we create an output. We calculate a lot of vertex position inputs with the help of this method. From there we get world space, for instance, and we do a similar thing with the normals, and then we assign normal world space, tangent, and bitangent. Okay, in world space. So it's this one. It's the output from the vertex shader, and usually the input to the pixel shader or fragment shader, but this time around we have a geometry shader in the middle. So the input to the geometry shader is positioning in world space, and normal together with its tangent and bitangent, all in world space. Any reason for text chord 1 here? Yo Poo, what's up? How you doing? How many times have you made a large scale game? None. This is pretty much the first time. Okay, so let's try and deduce what happens in the geometry shader. It was 6 months ago I wrote it, or maybe even 8. Let's see if we have some documentation as well to lean on. So HLSL geometry shader. Beautiful. I get it that it's exciting. I don't know if it's impressive, but thank you. Is this all the information we have here? Okay. Processes entire primitives. Max vertex count numverts. Yeah, that's what we're doing. So this one looks a little bit weird compared to what one is used to. Max vert count. That's what we have here. And then we have void geo vert frag. I guess that's good. Triangle varyings input 3. Primitive type triangle, data type varyings, which we define ourselves here, and the name of the input and how many it is. And then we have in out triangle stream, geometry output triangle stream. In out stream output object. Okay. Declaration for the maximum number of vertices to create. Okay. Point line triangle. Okay. Okay, so let's see here. We take the position from the first element in this input list. I wonder... So that's this one. Yes. Tangent to world, we create a matrix which transforms from tangent space to world space. Using the normal bitangent and tangent, great. Calculate random rotation and a random bend using these functions in the utility files. Might want to take this one and put it down here, I think. But let's do it like this. One sec. Or maybe like this. Or actually, and there we have it. There we go. This axis, and this is the rotation. Or the, let's see here. Angle and axis. Axis, and this is the angle. We calculate it by grass bend variation, and a random float. Okay. Then we get random width, random height. And then we transformation matrix. Yeah, okay, we transform random rotation and random bend from tangent to world. So this transformation matrix here is a rotation and bend transformation matrix. Then we create geometry output. I would like to read up on actual naming conventions for shaders. Like, choose one style. It feels a little bit like I'm all over the place most of the time. Although cell shade lit, use variance and attribute. Same here, but then we do geometry output. So position clip space, transform world to H clip. So geometry output, what do we have? We have position in world space, normal in world space, UV, and position in clip space. Let's put this one first. Okay, so this is where we build the generated triangle pretty much. So we loop through for each vertex, or for each triangle in the mesh, we take the position of the first vertex for each triangle, and then we generate a triangle on that vertex, and this is where we generate the triangle pretty much. So we take the position, which we get here, and we add we have generated the width we want, so we create one vertex. Let me open up a drawing software here. One sec, I just need to double check something, so I'm gonna be right back. Okay, back. Sorry about that. So what we do here is we create the new triangle by random width 0, 0. So that's going to be this point. And then we do minus random width. So that's going to be this point. And then we do random height. So it's going to be this point. And these are all located also at the position. So in an underlying triangle here, so it should be around here. I think this should be position, and this is part of a triangle in the underlying mesh. We generate the UVs as well, so each blade has a UV of... Oh, actually. So this one has 0, 0. 0, 0. One 0 and 0.11. I wonder if I want to change these two. I think I do. So if we draw this blade of grass here, I want UV 0, 0 to be here, 0 or 1, 0 and 0.51. Yeah, so we create each geometry output here, and it's a triangle stream. So we append them, so 3 vertices, and then we restart strip. So whatever we send out here, this is what the fragment shader gets. I wonder, do we really want it to get position VS? But maybe not. Okay, but I think that's a good start. Okay. So, let's see here. Oops. So, repeat current implementation, or refresh memory with current implementation. It was pretty straightforward, I think. Tessellate base mesh. I think that's what I want to do. Actually, let's put this one in. Okay, I want to tessellate the base mesh, and that is, so for instance, we have, let's say we have a plane that is made up of 8 times 8 vertices. Like I don't want the base mesh to be the sole controller of how many blades of grass there will be. So if we tessellate the base mesh, we can increase or decrease the number of grass. We're gonna do a lot of things with this one. I think the next step I want to do with the tessellation of the base mesh is to implement varying grass blade resolution. So right now each grass blade is only made up of 1 triangle, 3 vertices. I would like to be able to have a varying amount, so we're gonna have a property in the top that decides how many vertices a grass will be made out of. To start with, we're gonna base a lot of these things on distance from camera later on. So grass that is far from the camera doesn't need... We're gonna do some cheats to make it more optimized, but optimization, that's the last step. So let's do optimize base tessellation on distance from camera, base grass blade resolution on distance from camera. Although would love to be able to hack this even more. So like the first step of, like, let's say that a grass straw close to the camera is made up of, I don't know, 12 or 16 or 12 vertices, and a grass blade far from the camera is made up of 3 vertices. So like that's the first step towards optimization based on that. But I wonder if there exists way better ways of doing it. Like if we're far enough away from the camera, we just render a plane instead with a texture or something. Let's see if we can do tessellate the base mesh, and it's here. This might be troublesome. HLSL tessellation shader, tessellation stages. Okay, let's see. So probably want to put this between, or this should be, I think this should be executed between vertex and geometry shader. We'll see. Great. Hull shader stage. Okay. I wonder if like I would like to rename these I don't know, vertex input, vertex to geometry, or then it's going to be vertex to hull, hull to tessellation, tessellation to domain, domain to geometry, geometry to fragment. Fuck it then, I suppose. I can pretty much name it. Like, would have some guidelines would be nice, but GeoVert, as long as I'm consistent between my own shaders, it should be okay. Varyings. Do I want to rename this? So let's say if we only had vertex and fragment shaders, like vertex input, vertex to fragment. This makes sense for me. Oh well. Hull shader. I'm me, what's up? Is this your first time in geometry shaders? Yes it is, sir. If you don't count what we started with today, which I did like 8 months ago. But yes it is. Okay, with the low detail subdivision surface. Join the club. Yeah, it sounds like a club I want to join. I only know the basics from reading. Yeah, same here. Like I've known about them, I've heard about them, I've seen them being used, but me myself has never done anything with them. And I actually have a few things in mind I'm gonna do. The first being a grass shader, of course. So I really want to learn this from the ground up, like how to use them, the different stages, what it means, etc. So later on I know what the fuck I'm doing when I'm going off script, so to say. Okay, so this is the original one. Okay, so this is just visualizing the triangle, the neighboring triangles. Okay, and then we have the progression starts with a low detailed subdivision surface. The progression next highlights the input patch with corresponding geometry patch, domain samples and triangles that connect these samples. Through the tessellation stages. So I would guess this is the hull shader stage, and this is the tessellation stage, and this is the main shader stage. I would have hoped it was that. But okay, so I get what this one is visualizing. I'm a little like, is this the position? Is this the origin of the triangle itself, or? Okay, let's see if this makes a little bit more sense if we move on. I don't know why, like... I think, so this is a vertex. But like... let's see. Hull shader stage per patch. I would love to get... Okay, so we start hull first, and a patch can be... A patch can be either a quad, triangle, or line. Right? Semantics indeed. Okay, so the question is... let's move on and see if it becomes clearer. Once per patch, so once per triangle, depending on what you choose, like once per quad, once per triangle, or once per line. Transforms input control points that define a low order surface into control points that make up a patch. Ooh, black box level, love it. Then I don't need to care about what happens inside. Patch control points. So I guess patch control points. The control point for a triangle patch is probably the 3 triangles, right? Or is this the control point? let's see. Patch control points go in, we get patch control points out, and we also get a patch constant data. Between 1 and 32 control points. Okay. Tessellation factors determine how much to subdivide each patch. Okay, this is good to know. I'm late to the party tonight. Is any of this consumable by Unity? We'll find out, but I think it is. So, like, we actually have a little bit in place already. So we have a pipeline where we do a vertex shader, geometry shader, fragment shader. Pretty simple stuff so far. So we have vertex shader, geometry shader, and fragment shader. The geometry shader currently just takes, like, for each triangle on this plane, it takes the first vertex making up that triangle and generates one triangle on that point. With some, based on some properties, we have some bend, variation, and width and stuff like that. But so this is a simple geometry shader. What I want to do now is I want to insert a tessellation shader between the vertex and the geometry shader, because we don't want the underlying plane to fully control. Yeah, we don't want the plane to have sole control over how many grass blades there will be. So I would like to be able to subdivide this plane and then generate grass, or like subdivide this plane 4 times and then generate grass. And if we want to subdivide the base mesh, we're going to have to rely on tessellation shaders. I guess you could do it purely with geometry shaders, but that would be a mess. Okay, so the geometry node pretty much emits more geometry. The tessellation stage will, like, I guess emit would work for it as well, but it's more generate intermediate geometry, or like upping the resolution of a geometry. We want to go from a plane that is defined by 8 times 8 vertices to, I don't know, 16 times 16 vertices. I'm pretty sure, like, I've seen stuff like this been done in Unity, so I think Unity should be able to handle it. I'm pretty sure. Well, we'll see. At a deeper level, a hull shader actually operates in 2 phases, a control point phase and a patch constant phase. Okay. Okay, finally, a little bit of a example of a hull shader. So, need to remember this. Tessellation comes in 3 stages, so to speak. Hull shader, tessellation, domain shader. So let's see, hull shader. Patch size 12. Okay, patch constant func. Okay. let's take a look at this. How to create a hull shader. A hull shader transforms a set of input control points from a vertex shader into a set of output control points. To create a hull shader, design a hull shader, see how to okay. How to create a hull shader, how to design a hull shader. Ooh, nice. Okay, I love this documentation. Good morning, girls. How are you doing today? And welcome to Shaderland. To design a hull shader. Okay, for this documentation, I love it. Like how it's structured. Design it, create it. Okay, so input control point with output in the name. Oh, fuck. Input control point. Magic land for me. Hopefully it's a bit clearer after today. So currently this is magic land for me as well. So this is tessellation and geometry shaders, which I've never worked with before. Not usual for Microsoft documentation, right? Let's just say I'm shocked. VS, okay, what the fuck is this naming convention? Control point output, but this is the control input control point. V position, world position, okay. VUV, I don't know why they are using this prefix here. But okay, so input control point, world pos, UV tangent. Okay, so pretty straightforward. So this is the input control from a vertex shader. So, okay, pretty straightforward things you would output from a vertex shader. So, which we currently do. Let's see here. We output position, object space. No. Sorry. Here we position in world space, normal world space, and we also normal tangent by tangent. Okay. So everything except this. UV. Okay. And then we have output control point, and this one is a struct Bezier control point. Bezier pos. Okay, so define hull shader input control and output control points. Define output patch constant data. So this is something we want to do. And I also wonder, like, how would I want to structure my shader? Would I like to pair, like, would I like it so that this one is defined, then comes the vertex shader, then this one is defined, then this one is defined, then comes the geometry shader? Wouldn't that be a nice way to read it? But it's also very nice to have it like this. So maybe vertex input, vertex to, in this case, geometry, and then geometry to fragment. So you have it in that order, and then you have them. Because there's gonna be a lot of different data structures and a lot of different functions. That's for sure. Okay, define output patch constant data. HS. What are these prefix? VS. VS vertex shader, probably. Maybe. Yeah, okay, vertex shader, yes. And HS, that's hull shader, constant data output. Okay, so then this makes sense. So this is vertex shader control point output, makes sense. But zero control point. And then we have hull shader constant data output. So this is the output from the hull shader, and that also makes sense. So this is, where is my black box image? Here we go. Patch control points. So I suppose VS control point output. This one is this. And then patch control points and patch constant data. Patch control points is this one. And this is this one, patch constant data. Makes a little bit sense, right? What's up, Love? Good morning. Hope you had a great weekend. Okay, so this is slowly starting to make sense. Slowly. It was solid, nice, and happy Monday to you too. Okay, great. So we're currently working on shaders here, trying to do procedural grass, but I have a set of tutorials to lean back on if I need them, but I also want to go through this thoroughly because I want to understand all the aspects, because I'm gonna go madly off script later on. So I need to understand this stuff. Okay. For a quadrum, okay, yeah, I need to check this one. So what do we have here? Float edges, test factor. SV. What is SV for now? We have it in SV position. So types, data types. No, not types. Let's semantics. Thank you. System value, semantics. Okay, system value. It's for the rasterizer stage. System value. Test factor inside test factor. So is this tangent per, so we have edges here, 4, so we have 4 edges, but it's a float. Okay. But this 4 here, this tells me that we're working with a quad, right? So we have okay. For a quad domain, okay. The SV test factor defines 4 edge tessellation factors to tessellate the edges. Oh shit. So quad, when we see defines 4 edge tessellation factors to tessellate the edges. Since the fixed function tessellator needs to know how much to tessellate, the required outputs are different for the triangle and isoline domains. But like, what does this actually... SV test factor defines 4 edge tessellation factors. So is this that we want to split up each edge 4 times or into 4 pieces? Do we want to split it up like this? 1, 2, 3, 4, like in 4 pieces, or we want to split it up? Okay, so this is 4 pieces, or do we want to split it up? It should be 4 pieces, right? Like it doesn't, or like 4 cuts was my other option, but that doesn't make as much sense, I don't think. But defines 4, and is this like percentage? So tessellation factors. Let's see. Define a patch constant function. Okay, one input specifies a variable containing a patch ID and is identified by the SV primitive ID system value. One input parameter is the input control points. VS control point output. Okay. As a minimum, the function must calculate per patch tessellation factors for the tessellator stage, which are identified with SV test factor. So per minimum, this one must be calculated. I wonder if this... a quad domain requires 4 tessellation factors for the edges and 2 additional factors for tessellating the inside of the patch. 4 tessellation factors. Okay, so far we have defined hull shader input control and output control points. So input and output control points and the output patch constant data, and also a patch constant function. A patch constant function is used to generate the output patch constant data, if I understand it correctly. So vertex data from the vertex shader to the hull shader. One of the outputs of the hull shader, the other output of the hull shader. And then we have this one, and this one creates and fills this one up. And then I guess the hull shader, the other part of the hull shader. So the hull shader uses both the constant function and generates this output. Let's see. A hull shader identifies the properties of patch, including a patch constant function. A hull shader is invoked once for each output control point. Domain quad, partitioning integer, output topology triangle CV, output control point 16. Patch constant func subdivide to Bezier constant HS. So it's this one. Jesus. It's a domain attribute, partitioning attribute. So domain, pretty straightforward. Partitioning, let's take a look at that one soon. Output topology, output control points, so just a number of them. And then we have patch, okay, this one just defines the patch constant function, I guess. The hull shader run insert code to compute output here, VS control point output. Whoa. Okay, so this one also outputs this one. It looks like. So my question then, the fuck? The fuck, is this a mistake or is this actually how fucked up it is? So like sub D to Bezier HS should return Bezier control point, but here we create a VS control point output and returns that one. I would have thought like this is returned by the hull shader, and this is returned by the patch constant function. So far so good. Then we can get this result, like but this, okay, let's see. But I also want to do domain I get, partitioning I get, this one output topology. I get it, but don't understand this. So let's see, I get this and this. So let's see, partitioning, okay, output topology defines the tessellation scheme to be used in the hull shader. So this is integer. Can be integer, fractional, even, fractional, odd, or pow2. These are the principles of following types of shaders. Okay, but no examples, no nothing. I guess integer is the fuck, like tessellation scheme. Is this? Is this common knowledge, like tessellation scheme? Integer. Let's see if this one has some more information. Ooh. Fractional. Okay, this one has a lot of information, but I want to know, do we have something like this? No. Do we have fractional even? We had something like fractional even. Okay, so here we do. Okay, so I guess it's equal spacing is, could that be integer? And then we have fractional even, fractional odd, fractional even. Is this spacing? Partitioning, like maybe, probably. So integer is integer slash equal spacing, if this is it, if it's the same thing. Pretty cool, pretty cool. So I'm just gonna move on as assuming this is it, but I'm not, like, when a documentation is this short and you just define it like this, then what that tells me is that, okay, this is some like standard that it's pretty well known. Output topology defines the output primitive type for the tessellator. Yeah, makes sense. Point, line, triangle, CV. This is my big question mark here. CV. CV. Counterwise, or clockwise and counterclockwise. Could it be that? So output topology clockwise, which is the north. Okay, it's probably that, right? So we can output a point, a line, or a triangle counterclockwise or clockwise or counterclockwise. Okay. Okay, so designing hull shader, creating hull shader. Okay, so this maybe not that relevant here. Okay, before I jump into this one, let's continue. Search one coordinate system. Okay, so yeah, okay, so when we send in a quad, the coordinate system is 0 to 1 in X and Y. Makes sense. And the type of partitioning which specifies the algorithm used to slice up a patch should be this. The tessellator outputs UV to the domain shader state. Internally. Okay. So tessellator stage, I don't need to define anything here. Like the hull shader sets it up, and then the tessellator stage happens, and or yeah, we don't need to do this. I hope. And then we have the domain shader stage. So hull shader output control points, tessellator stage output texture coordinate. Okay, hull shader output control points. Okay. A geometry shader that expects primitives with adjacency, for example 6 vertices per triangle, is not valid when tessellation is active. This results in undefined behavior which the debug layer will complain about. Okay, good to know. So you can't do a geometry shader using triangle ADG if you also have a tessellation shader. But point line, so line adjacent, is that okay? Primitives with, okay, so it's not triangles only, it's, okay. And just an example. Okay, so anything ADJ doesn't work with tessellation shaders, so only point, line, and triangle. I'm like, good to know. For this use case, for the grass, procedural grass shader, probably just gonna work with triangle. Like, I want to work with points later on, but oh yeah. Okay, so for this case it should be okay. And domain shader. My domain shader output, like I did, the naming convention here is all over the place. My output, that's my input UV domain point. Okay, for now, first of all, okay, we have this. Let's just do should be able to just do maybe not. Let's do this and Oh no. No errors. Oh yeah, because position CS. Okay, better. Let's just keep it like this for now when we're gonna insert the tessellation here as well. Because I think this is gonna be messy. Let's just look through this one first and step back to this one and see if we can create our own. And ensure, and it's going to be chaos. Declare the location on the hull with the domain location system value. For a quad patch, use float 2. For a tri patch, use float 3. Barycentric coordinates. Okay, I get it. So declare the location on the hull with the domain location system. For an isoline, use a float 2. Isoline, I have no idea what an isoline is. But so for a quad patch, we're using a UV coordinate system of like X and Y, so I guess it's just a simple coordinate system. So 0, 0, 1, 0, 1, 1, 0, 1. And when we work with triangles, we base the coordinate system on all of these three with using barycentric coordinates. It's been a while, but it's like an interpolation between these 3 points. I think that's the good way to look at it. I always thought about it like, how much does this point pull on the point? Okay, but yeah. I wonder if I want to work with quads. Like, quads feels a bit more natural, but okay, so float 3 UV SV domain location for if we're doing a tri patch. Define the other inputs. Okay. The other inputs come from the hull shader and are user defined. This includes the input control points for patch, of which there can be between 1 and 32 points, and input patch constant data. Need to get to the bottom of what this actually is. But okay. So the input here is both output patch. Oh, let's see here. Okay. And this is the output from the domain shader. DS output. Is this how I want to name? Yeah, I think this, something similar to this is the naming I'm going to do. vertex input, vertex output, geometry output. So short for vertex shader input, vertex shader output, geometry shader output. Yeah, it's pretty nice though. Okay, so instead of the vertex shader like outputting this for the fragment shader, we do it here. Quads is much easier, you know it, I know it. Let me pretend. The function takes each input UV from the tessellator and evaluates the Bezier patch at this position. Okay. We're doing it with... Okay. Bezier eval domain space. Okay. First of all, attributes vertex input, vertex output. Fuck, do I wanna vertex shader input? Does this look better? Oh, I think it does. I want to be like extremely clear here on my naming. I want to be explicit as fuck, because I never want to like look at a variable and like what does this mean? So vertex shader input, and I do like this. Vertex shader output. So right now we're gonna ignore the geometry. Shader output. We're just going, right now we're going vertex shader, fragment shader. And I wonder if I want to name this as well. Vertex. Oh, this sucks. Oh, this sucks. Vertex shader. Fragment shader. Geometry shader. Liked. I think I like the look of this. Fragment shader. Float for fragment shader. Vertex shader output input. Love it. This tells a story. Okay. Vertex position input. Yeah. So we want to define hull shader input control points and output control points. Define hull shader input and output control points. Input control and output control points. Yeah. But shouldn't this be my vertex shader output? I think. Pretty sure. Vertex shader control point output, yes. Yes, it is. So I want to define this one and this one. So vertex shader input, vertex shader output, struct hull shader control point output. We're doing extremely long names here. And struct hull shader, and I want to name this patch constant data output. That makes sense, right? And we just want to do position here. Bezier pos. So this one is in world pos with the same. So that makes me want to do float 3 position vs Bezier pos. In world space. But that's not Bezier pos. Might be interesting. Let's save that one for later. But semantics, do we have it here? We don't even have it here. Because I wonder, I'm starting to think that this is probably not in world position, but rather in some other space. So let's just name it position for now. What space or coordinate space? Done. Okay, so let's think about. Let's look at this one right now. H as constant data output. Subdivide to Bezier constant hull shader. Subdivide to Bezier constants hull shader. Would have loved to see this. The fuck? Okay, this might be time to check out this one. I think I've looked upon something else Ned made, and he does good stuff. He does good stuff. So let's see. Mm-hmm. Triangles, okay. Hull function also receives an index specifying which vertex in the patch the hull function must output data for. Okay, it runs once per vertex in the patch and can look at all vertices in the patch to produce a new data structure for later on in the chain. Yes. So the hull function referred to here is the hull function is this one, and the patch constant function is, no, this is the patch constant function, and this is the hull function. Me, what are the other streaming services? Twitch. Non-programmable stage called the Tessellation runs. So this one prepares it for the tessellation, right? Yes. The domain function is where a lot of your logic will go, okay. Much of what you'd usually do in vertex stage should be calculated here instead, including clip space positions. Crucially, you can reposition vertices in domain state. Okay. Great summary, I think. So this is pretty much how I thought it, how I think about it after reading the HLSL documentation. So let's continue. Shader target 5.0. Whoa. I want to see the complaining before I change it, but let's see here. Vertex shader, geometry shader, so let's do pragma hull shader and domain. Looks about right. Might need Tessellation. Tessellation. Converts position and normals to world space. Great. Notably, the position semantic is forbidden. Okay. Is that true? So currently we use SV position. So tessellation control point is vertex shader output. So SV position, yeah, that's probably not what we want, but internal tessellation position. We'll already do all of this, maybe not this, but or do I? Let's see. No, we don't. Okay. Let's start with triangles here as well then. Partitioning tells the tessellator which algorithm to use to subdivide. Great. Triangles, output control points 3. Okay, so one, like each point of the triangle. Triangle clockwise. And here we're going to reference the patch constant function. Partitioning mode integer. And here we are going to have, okay. So then I want to put it here. Hull yes. Yes. Patch constant func. Yeah, this one we're gonna change. But we're partitioning integer. Yeah. Fuck it, can I? Probably can't. Let's see if we rename it. So tessellation control point, this one we're gonna change to hull shader control point output. This one hull shader. Tessellation control point is the vertex shader output, I think. Patch, yeah, let's keep it like that. ID, SV output control point ID. Okay, return patch. So right now, just return this. Okay, so it signals which vertex in the patch to output data for. Okay. Oh, one sec. The patch constant function, okay. So I want to do something like hull shader. Yeah, let's put it here. Actually, let's do hull shader patch constant data output. Patch constant, I can name it whatever I want. So let's do hull shader patch constant function. And we want the same input. Set up instance. Now what do we have? Tessellation factors F, we just create that one. I think I want to do actually hull patch constant function. Okay. Edge 3. Okay, we have 3 edges on a triangle, and that's the test factor. And then we have inside just 1. If we compare it to hull, if we do didn't we have it here? Oh yeah, here. 4 edges for a quad. Inside test factor 2. I'm not entirely sure, but like inside test factor. Okay, this actually should contain the tessellation factors specified per edge on the triangle using test factor. Edges are arranged opposite of the vertex with the same index. Great. Send the tessellation factor tag with SV inside test factor. Soon we'll visualize how these factors affect the final. Okay, great. Love it. So this one we just tessellation factors pretty much. So want to define float edge okay, so this one makes sense now. Float inside, or is it tests inside factor? Inside test factor. Okay. So how many times we want to tessellate the inside? Let's see. So output dot edge and inside edge. Let's start with 1. So 1, I wonder if that means that we tessellate it once or we just output the input. Okay. And here we're gonna do hull shader patch constant function output. No. Hull shader patch constant function. Okay, it's clearing up. But for now, realize that an edge factor is the number of times an edge subdivides, and the inside factor squared is roughly the number of new triangles created inside the original, and the inside factor squared is roughly the number of new triangles created inside the original. Okay. The patch constant function can also output other data, but it must be tagged with a semantic like always. The special Bezier pos semantic is useful since it can take the form of float3 array. Later we'll use it to output control points for Bezier curve-based smoothing algorithm. Beautiful. Okay. With that, we're done with the hull stage. So here, just the patch is returned. We don't do anything. And here, all the test factors are set to 1. Realize that an edge factor is the number of times an edge subdivides. Domain quad, domain try. Okay, so the patch constant function output goes here. And then we have float2 UV, because this one is a quad, but we're gonna have float3 barycentric. Well, name it whatever we want. SV domain location. Yes. And then also the patch goes here. Okay, so this is the output from the hull shader. This one, I think. Pretty sure. Yeah. So hull shader control point output, hull shader patch constant function output, struct domain shader output. So domain shader output, domain shader, and the input should be hull shader patch constant function output. What do I want to name this? I want to name this interpolation test factor, maybe. Let's see, what do we have here? Factors. Yeah, that's a good name. And input. And bez patch. So patch, and depends on what we're gonna do with it later on, but let's go. I like this more. Hull shader control point output. But we need to what was it? Output patch, and then hull shader control point output 3, right? And patch. And lastly, it was the I want to see if I can remember. Oh yeah, the barycentric coordinates. So I don't remember. Float 3. I want to call it. I want to call it UV barycentric. I don't know if that's how you spell it. And then I don't remember exactly the SV domain location. Barycentric. Something like this. Fucking chaos here. Do I want to keep this clean? Do I want to do... And... maybe. Mars Live, thank you so much for the follow, appreciate it. Instantiate the output, do Unity setup instance ID and stereo support. I don't care about VR, but I need to research this, definitely. And then do we want this function? Might be good to have. But probably want to do, I don't want define, maybe a bit more optimized, but I think I want it as a function and I want it in my utility math here. So what do we have? We send in a float 3 and it returns a float 3. But then of course then we need to times that one plus that one times that one. Fuck it, let's do it with a function. So is this actually referred to barycentric coordinates? This is more like the... Like this one returns the barycentric coordinates. This is more like the points making up the triangle. Or... Are they actually referred to as... The barycentric coordinates of a point can be interpreted as masses placed on a to a simplex, a triangle for points in a plane. A simplex. Cool. Every point has barycentric coordinates. The sum is not 0. I would like to have get the term for the points making up the triangle in question. Okay. Percent. Yeah. The 3 numbers indicate the barycentric coordinates. Yes, exactly. Okay, yeah. Of the point R with respect to the triangle. But don't we have a term for the actual triangle? Or something to refer it with? Maybe not. So what do I want to call it? Float 3, calculate barycentric coordinates for calculate barycentric coordinates. Sec. UV barycentric Oh yeah. Oh, okay. So what we're actually doing, oops, are. Oh, I'm tired. He's completely correct. I'm in the wrong. So we already have the barycentric coordinate. We get the barycentric coordinates here. So this is a vector with where each value is between 0 and 1, and this is the barycentric coordinates. So what we do here is a barycentric interpolate. So we want to get the position in world space given the barycentric coordinates, right? A little bit. So where's this one coming from? A little bit worried about, shouldn't this be, let's see here. This should probably be, I'm probably wrong again. It should be tessellation control point. Shouldn't it be patch? Wait. Is it possible to write it like this? Field name. Oh, yeah. Okay. I get it. I get it. Yeah, it's me that's off again. Okay, I promise. From now on, no second guessing. So, I want to do this as a function instead, I think. So we're gonna do it interpolate barycentric float I think we're gonna do it like this: float 3 barycentric coordinates and So I do want a term for the, like, the triangle making up, or the points making up the triangle. But interpolate barycentric. Okay, so maybe we're gonna keep, so this is gonna be the T. Let's name it T. So if I want to implement another interpolation technique here, yeah, let's, and in fact, I want to name this one. We're gonna do it for all three. P1, P2, P3. So 3 points making up a triangle, and then we have the barycentric coordinates. So return, what is it? P1 times Tx plus P2 times Ty plus P3 times Tz. I think interpolate barycentric. So that's gonna be, we want to do a few things here. We want to do domain shader output. Output is equal to want to do this later on at least. Then we want to calculate the position world space, the normal in world space. So interpolate barycentric and P1, P2, P3. What do we have? Patch 0 dot position vs patch 1 in fact, am I gonna have, yeah, I'm gonna have to do this with all of the things I want to continue on, but what do we have? Vertex shader output, that's hull shader control point output. That's not at all what we're working with. Position world space, normal world space. What do we do here? Oh, okay. I don't know. Okay, so in this case, the vertex shader and the hull shader actually returns the same thing. So I should do, in my case, that would be hull shader control point output. Here we just want to do vertex shader output. I'm not entirely sure this. I want to do it later on. So here we, fuck it, let's do, I want to keep it hull shader control point output, hull shader control point output. Okay, vertex shader output. I wonder if, let's do it, position, what coordinate space, so this is in this, I want to change later on. Not too sure about this one. Yeah. Let's clean this up a bit. Position normal tangent. Position CS, we're not gonna have position CS here later on. We're just gonna do it down here. So let's remove it now. We're gonna have position world space though, and it's going to be position normal world space normal. Wonder if I want to keep this as text chord. Ooh, tangent. Actually, do we have tangent? Let's see. Semantics. Tangent by normal. Beautiful. But normal tangent yeah, normal tangent by normal, I guess. Okay, and then we'll go here, float 3 position world space. Ooh, this is where we need to do, so internal test pos, hull shader control point output. Here I pretty much want the exact same thing, so I just want to send this onwards. I think we can do it like this. So this and this. I identical, except for... So what I want to do then in not this one, but this one, we don't want to do this, that's wrong. We want to do hull shader control point output is equal to put output. No, 0. And basically just do we have patch? Yeah, and this is ID, so I guess I want to do output dot position world space is equal to patch ID dot position world space. Output dot normal something like this. By tangent. Okay. In its current form, could probably use this one for both. Change this one to internal test pos, but you never know. So vertex shader gets vertex shader input, outputs vertex shader output. Hull shader control point output takes vertex shader output, convert it to hull shader control point output. Then we have this one, and okay, let's move to the domain shader output again. So this patch 0 position vs. So now we're working with hull shader control point output. We have it here. We take all of these 3 points. Position vs. And we want to interpolate it with the UV barycentric. Fuck it, let's rename it barycentric coordinates, or barycentric coordinate. Like this. Do I want? Yeah, maybe. The worst part here is that we probably need to do this with the normal, the tangent, and so on and so on and so on. Pretty sure. Would be nicer with a macro like this, but nah. Domain shader output, what do we have here, by the way? Domain shader output, nothing. Text chord, okay. Do we actually want to work with the text chord here? That's weird. That I need to figure out. Yeah, so what I want this one to return is float 3 position in clip space, because what we output from the domain shader is usually going to go to the fragment shader, which won't be our case later on, because we're gonna make it go to the, we're gonna put in a geometry shader between the domain shader output and fragment shader. But for now, during testing of this tessellation, we're gonna go domain shader, fragment shader. So we need SV position. Oh, is that one in full caps? Come on. And then float 3 position world space. We're not gonna need these now, I don't think, but I want them later on. I don't know. Okay, so this one is the weird part. Text chord 0, 1, and so on. Text chord 1. I don't know about it, but let's see. Normal VS. Probably some reason. Okay. So, back to this one. Probably want to do position VS, normal VS. What's up, Justice Boom? Float 3 by tangent. Do I call it by tangent VS? Yeah. Generally, I'm working on a creature collecting and management game, and specifically procedural grass. But we're doing procedural grass slowly and thoroughly, because I do want to understand each step here. So now I guess it's just output dot position VS is equal to position VS, output normal VS is equal to normal VS, and so on and so on. Can you show it? Not right now. I think we're gonna have a lot of shader errors. Maybe it should be okay. Soon we can show it in its current state. We don't have that much functionality, actually. It's more just of a visual demo, I would say. But Justice Boom, down in my channel description I have a few videos of it, so you can get the general feel of it, because I don't know how far away we are from actually playing it right now. So I recommend checking out those videos, and then you see how it looks. Okay, I think this is all I want to do here in the domain shader. Is it like Pokemon? Not more like Viva Pinata, if you play that game. So more like Viva Pinata. If you haven't played Viva Pinata, I do recommend playing Viva Pinata. return output as well. Do we have it here? Ah, that's good to know. Return output, return output, return output, and return output. Actually, I think it's like this. They might have a weird end, but you should probably get it by just writing this. What do we have here? Return. Yeah. The domain function also has a domain attribute. Yeah, that should match. Do we have it? No, we don't. Okay, let's see what kind of errors we have so far. And thank you for the follow, Justice Boom. Appreciate it. Okay. Syntax error, unexpected token, vertex shader 125. Good start. Vertex shader. Why am I missing? Oh. Could it actually be? Yeah, macro redefinition. Yeah, we don't want to read. Let's go. Let's keep it. But this one, syntax error. So probably we need a semicolon somewhere. Do we need this or something of the sort? Unexpected token vertex shader. I'm missing, like, this feels like a semicolon somewhere. Okay, before I continue fighting with this code, I'm gonna need some more energy. So I need to run AFK real quick, around 5 minutes, and then let's find the cause for this. So be right back. Okay, back. Let's see. So syntax error, unexpected token, vertex shaders. So what this tells me, questioning myself here, is that something before this one is wrong. Like, I would have guessed missing semicolon, but it doesn't seem to be the reason. We have Pragma vertex shader here. Is it? I don't think it is. Normal tangent. Normal 2. Fuck. Unexpected token vertex shader. Fuck. Yeah, then we don't even compile it, I suppose. What am I missing? A vertex shader. How the fuck can it fail here? That's vertex shader output. This one is correct. Vertex shader. This one is correct. Guess we can. should be. I don't understand this at all. Is it? No, this shouldn't be it either. Unexpected token vertex shader. The fuck? Is, oops, can you actually not use vertex shader HLSL? So is it just that I can't name it vertex shader? Is that the problem? Or do we have something in core HLSL? Extremely weird. Okay, if I can't use that terminology, what can I use? I could just name it vertex. Don't like the look of that. But that works. Okay, let's continue then. $134. Output position CS. Okay, so one of these is wrong. Vertex shader output. Yeah, we don't have position CS here anymore, so let's remove that one. Syntax unexpected token hull shader. Can't I? The fuck? Oh, no, no, no. This one I want. Oh, yeah. Domain shader. Okay, so I can't name them domain shader. That is weird. Okay, SV position is invalid in 5.0. Oh yeah. Is it? Okay, let's see. 125. Oh, is that so? But it is the first position. Is it? Whoa, whoa, whoa. Do I have two? Oh, this is not good. Let's comment this one out. This feels wrong. And what's up, Smack My Peach? How's it going today? It went pretty good until about 30 minutes ago, I felt, but we'll see. Okay, yeah, I know. Okay, let's see here. Domain shader output. Let's put. We have SV position, domain shader output. This is what we want here. I thought. Fuck yeah. That is true. We also want to calculate position CS here. So we still have this error. That's weird. Implicit truncation, I don't care about that, do I? Or is it... Yeah. Beautiful. Not exactly what I want to see so far, but we'll see. Do we have something else? 126, 169. SV position. We only have, it's only defined in domain shader output and in geometry shader output, but that one is commented out. So the fuck is it complaining about it here? Not all elements of SV position were written. Okay, so let's take this one for instance. Not all elements of SV position were written. Output signature parameter SV position. On line 126. 126, we're working with vertex shader output and vertex shader input. Vertex shader output doesn't have it. Not here. And then we have the same error on line 169. Or input signature parameter must be. Ooh, position. Oh yeah, is this? There we go. Okay. But this is the exact same result. We haven't done anything to it, which I find to be weird, I think. Let's see. It's still... Actually, I'm not seeing anything. There we go. Yeah, it's not subdivided at all. Extremely weird. Should be able to see it with wireframe here as well, I think. Okay, but no subdivision as of now. So let's get to the bottom of that. Okay, we haven't done it yet. Let's see. So, I wonder... No subdivision. Okay, so here we go. Factor edge 1, 2, 3. A factor inside. Okay, so what I want to do in my case is I don't want separate ones, I don't think. We're going to see here header, grasp, and grasp proportion. Let's put it here. Subdivision maybe. Let's see. Subdivision. subdivision. Okay, so I want to try and do this. This one I think I want to do power to the power of 2, but I'm not sure. 2? Oh, beautiful. Looks not exactly how I would like it though. Fucking weird. 1, 2, 1. Okay, so I want to see what happens if I do pow 2. Jesus. So what happens if we take this triangle, this patch, we divide it once here, and once here. On the edges, and then we get 1, 2, 3, 4, 5, 6. I don't know. I would have hoped that the subdivision would be one here, one here, one here. That would be extremely nice. Let's see if we can control that in some way. The integer mode divides a number of times equal to the ceiling of the tessellation factor. What do we have? Let's see. Vertex shader, hull shader control point output. This one pretty much just sends onward the vertex output. We define the subdivision per edge, and we have inside. Like this makes this one makes the least amount of sense so far. Everything seems to work. Beautiful, but I would have hoped that the tessellation was... Actually, I need to... Let's take a look at... inside. I wonder if I can recalculate this one in such a way that we get a little bit of a nicer... But it do seem to be ignoring it. So right now it's 2. I don't... Okay, if it can... It seems to have a minimum, but if it can... Like, if it's more, it does more. Okay, so that's good to know. Ooh, nice. Let's try. I want to check out. So what do we have? We have integer. I want to try the other ones. Partitioning. Fractional even. Okay. And the last one, POW 2. Extremely similar to integer indeed. Let's go with integer. Okay, let's reintroduce the geometry shader here. Oh, one more thing. Like this, I'm a little bit annoyed still that I can't name this shader. I don't know. Fragment shader is okay though. Wonder if geometry shader is okay. Did not find. Yeah, that's okay. Void geo, yeah. Let's geometry shader. Let's go. And then I also want this one void. Oh yeah, we go in out here. But we get the same syntax error. This is weird. So then I want to do, let's just call it geometry and this one shader. Or this one fragment, I mean. And geometry. Geometry shader output, vertex shader output. We're going to rename those as well. So let's see here. We want to go domain shader output. This should be the input to the geometry shader. And then we have geometry shader output here. So this one shouldn't have position CS. Position VS, normal, tangent VS, okay. Domain shader output, geometry shader output. So here we remove this one. Domain shader output, void geometry triangle, domain shader output, input, in out, triangle stream, geometry shader output. This one is okay. And here we should have geometry shader output, input. Beautiful. So now I should be able to do. Okay, so these are the number of grass straws we get with a subdivision of 1. So just the original plane. Then we go 2, 3, 4, and so on and so on. Beautiful. Good start. Although this setup means, like doing it like this, grass width and grass width variation, means that we basically get, we can get grass straws that have a width of 0. So I don't know why I settled on having a base value and a variation value when min-max is probably what I like the most. because then we can just do a simple lerp. What do I do here? Random float. Oh yeah, so we changed it from the domain 0 to 1 to -1 and 1. Grass width variation. Yeah. Fuck that. Let's go with... What the fuck did I do it this way for? It's just way more ugly. Random float times 2. Random rotation is good. Random bend, random width, random height. I want to do... Tessellate base mesh. This one is done, by the way. I think I want to do grass bounds. No, grass width bounds. To vector is equal to default value of I think I want to do something like this instead. And then we do down here when we use it. I think this will look way nicer. So random bend, grass bend variation. Oh, I didn't change grass bend. Okay. Grass bend as well. think this is a much better approach. Removes the possibility of grass that is 0 high or 0 wide, at least. 223. We're gonna keep them as 4 for now. Okay. But bend. What do we have? Random bend. So this one is a value between random float between 0 and 1. So max bound, min. Should be okay. Or am I seeing some weird bending proportions? No. Okay. Grass bottom color, grass top color. Are we not using this one anymore, or are we not generating correctly? I thought we used it before. Maybe we... Oh, yeah. Okay, now we're back at where we started, but with the possibility to subdivide it. Although, I'm seeing... Am I seeing repetition here? Or is it just... Is the subdivision? Don't think there's any sub. And then we have like how the outlines are handling this grass. So I think this is probably how I would like it to be handled. Yeah, it definitely is. So no complaints there. Or what do we have? That's pretty tough. But it looks pretty nice. Looks promising indeed. I think so. Looks a bit... Although okay, it looks pretty fucking good, and it's still as like there's so much more to do. I'm a little bit, so this is, it's pretty heavy calculation wise. Is it the tessellation that takes the most? $15 is way too much, but this is probably more like it. I mean, it's also easy to have this as a graphical setting, because yes, it's just a simple subdivision like this. Do I want to? Yes, I want to. Let's see. Procedural grass material. Let's take this back to 1 and see how it looks on the terrain. Or are we gonna get... You don't really need so dense grass when the ground has a similar color. Yes, that was what I was thinking as well. And that's good to know. Where do we have it? We have it here. Prototype blue material. Yep. Yeah, we want to keep the original mesh as well, I think. Like at the subdivision. Oh, I know we have. I know one thing we want to fix as well. Definitely. So right now in the geometry node editor, we're pretty much ignoring. No, we're not lowering by distance. Not yet. Not yet. There's a lot of things left to do. Like this is just a start. So we're not doing anything of these just yet. But you can also see these lines here. I'm gonna hopefully fix those. A lot of things left to do, so let's see. first of all, I want to start by doing these lines we get here. And if we check, if we don't do any subdivision, we can see here that there exist points where we don't generate grass blades. These ones. So the last line here we don't generate for. Which results in this weird banding artifact, I would call it maybe. So that's one thing we want to fix. And I think it's thanks to this one. Triangle. Don't I want to go with point here? Can we go with point? Geometry. We can do point. Math. Rotate Y based on output from Perlin noise would randomize it a bit. Oh yeah, definitely. We're gonna do a lot of those as well. It's great input, by the way, Harukanan. Both, like, you don't really need so dense grass when the ground has a similar color. That one is nice to know. So when we generate the grass, we're gonna keep the underlying mesh and we're gonna randomize the color a little bit, probably with Perlin noise as well. And then we're gonna color the lower piece. The lower color of the grass is going to match the ground color, if that makes sense. And then we can vary it the further away from the ground it is. But let's see here. So we're missing, like, we're not generating grass for these vertices, and that's because we do. I thought it would be one of these lines as well, because if we take the geometry shader, we get triangles, and each triangle has 3 points, and we just take the first point and then we generate triangles for them. We don't care about the other points. So can I do? Fuck. But I think it's pretty, yeah. So, and that this issue persists between each subdivision, because we can see it here, like we're skipping. This makes it so much more visible. But here we can also see that we skip in this direction. Let's see, 10, yeah, much more visible. But So my only question, I have a few actually, but like we get grass straws here, we get them here, so it's only for this line. I would have understood it a little bit better if it wasn't this line and this maybe. I don't know, but the issue is because of this. And then, yeah, that seems odd indeed. Indeed it does. But if I could do, let's do, actually let's do, it seems really odd. We have a plane. Let's just go like this. Let's make it easy. Okay, so for each triangle we take the number 0 and we generate a grass straw here. So this one, and then this one, and this one. So this point is these two, and then we do the same here. So it's going to be this. One sec. Okay, so this one, this one, this one, this one. Right? So this triangle, this one, this triangle, this one, this triangle, this one, this triangle, this one. That seems odd as fuck. So what do we do with this triangle then? I need to analyze this. Hello sir, what's up Fabic? How about shifting each vertex by some amount and then tessellate the triangles? You mean to add some randomization or something like that? Could probably fix it, but the underlying problem would still be there. This is pretty odd. I want to get to the bottom of this. As I said at the beginning of the stream, I want to understand this. Yeah, Harukanan, that is definitely true. So for this triangle, for instance, you already have 3 straws, so I've only drawn straws for these triangles right now. So, which means that for this one, you can't draw it anywhere, right? And same for this one. So, let's take a look here. I might be misunderstanding something. So yeah, we must have double straws here, I think. Pretty sure we do. But then with the same logic we shouldn't have. Okay, I guess it depends. So for this, let's say okay, so this is it. So for these circles here are for let me draw it like this instead. So this one gets its there, and then we have blue there, and let's say that we draw those in the bottom right. So we draw them here, 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 and here, and that explains it. So that's why only this line is empty, And we actually get... the fuck? My mouse died for some reason. That's weird. Yeah. Ah, nice. So that's why this one is empty and we get double straws here, which means that doing it with a triangle in Geometry Shader is probably not the correct choice. So we want to change this one to point. Okay, my mouse has like 0 battery right now, and I think it's using it up quicker than it can load. So before we continue here replacing triangles with points, I'm just gonna go and grab a new cup of tea and be right back for 5 minutes and let my mouse load a little bit. So I'll be right back, sorry about this. Okay, back. Sorry about that. New mouse funding page. It shouldn't be that bad yet. It should be okay. It should be okay. I wonder though. It seems like something is wrong. I wonder. Like it seems to be stop recharging it when I'm using it. I don't know. Let's see. And by the way, maybe change the polling rate on the mouse. There's absolutely no need for it. Tell that to a Counter-Strike professional. Nah, but it probably isn't. We'll see if my mouse will stay alive now or... Okay, yeah, so we had this idiotic mistake. So 2 grass straws on the same place and we miss a row. And when we do geometry shaders, we can either work with point, lines, line adjacents, triangles, or triangle adjacent. There's really no reason to work with triangle, I don't think. I can't think about a scenario where I need, or where we need, the data from the other vertices. So right now we're just using it to generate grass on each point. So let's work with point, see if we can make it work. So let's try and wing it. It should be max vertex count. That one I need to check. Declaration for the maximum number of vertices to create. So yeah, that's still gonna be 3 for now. We're gonna up the resolution of the grass straws later on. But this one, domain shader output, domain shader. Yeah, it should be okay. So point 1 output triangle stream. I think we want to keep it like this. So this and this is the only place where we change it. Let's see. Okay, still got the same issue. That's almost even weirder, I think. So, point. You operate on only one point at a time. That's okay. Interesting. So this changed nothing. The fuck? Or am I just missing something? HLSL geometry shader point missing points or missing vertices, not generating geometry for some vertices. The input primitive type must match the primitive type used with the drawing command that renders with the shader. Okay. Okay. So, can probably not use points, but need to use triangles. Mm. Okay, this is very interesting, but oh, so that's how you do it. Can you change this? But okay, so this is very good to know. Very good to know. But how can one... So, could do something like this, but the problem is... Probably want to render the base mesh as well. And my guess is that that won't be possible if we change the mesh topology to points. But let's see here. But but doing this will still not remove the... It will fix the missing quads, but it will lead to even more duplicate quads, won't it? But doing this will also lead to 2 meshes, and I want to avoid that as well. Okay, this is hard. So this can't do this because we're drawing the mesh with triangles. What happens if the domain is changed? Ah. I want to find a way. Shit, how can I find a way? I want to see if I have duplicated grass straws, and I think I can find a way for it. We're gonna do plane, and we can do a lot of bending. But the random number we use for the bending, I think we're gonna do, if we can, so what do we have? Random bend, we use pos yzx. Let's try float seed is equal to input 0.x or dot position vs dot x plus input 1 dot position dot x, and doing this will hopefully give a different seed. I think it will per, so the same vertex, if we generated the grass straw 2 times for a vertex, we do it 2 times from, or 2 times from different triangles, which means that this seed will be different, and we will be able to see the we'll be able to see the double straws, I think. Array index out of bounds 0, 1, 2. Oh, we're still working with points. So what was it? Triangle and 3. Yup. So a lot of double straws, confirmed indeed. But how the fuck do we solve this? So we can't, okay, so if we want to do points here, we need to change the mesh so that it's rendered by points, but then we won't be able to render. So for instance, let's say that I want to use this shader on the terrain. But I also want to render the terrain. I just want to add additional grass straw here. Annoying. So, what's up, Tan? Today we're trying to generate grass, or do procedural grass. So it has been a very... I've learned a lot so far today. And okay, so the question is, here is something I thought we could use to solve this. So I was thinking, oh, can we use triangle adjacent instead, and like then we have more information to go on, so we can like double check so we don't do duplicated generation of grass straws. But triangle adjacent doesn't work. Anything adjacent doesn't work with tessellation stages. A geometry shader that expects primitives with adjacency, for example, blah, 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 is not valid when tessellation is active. So we can't use that. Looks spiky indeed. Yeah, we're pretty early. It's gonna look beautiful in a week, I think. So, with this information and only this information, can we generate straws for a vertex? So, I want to generate them for all vertices, but like, can we play with the information, or can we... Actually, we don't have double here. We do have double here. We don't have double here. probably makes sense. But like, can we work with this triangle in such a way that we generate grass straw for each vertex, but only once for each vertex? So we want to include these 1, 2, 3, 4, 5, 6, 7, 8, 9 grass straws here, and we want to remove the duplicated here. I don't know. What information do we have to play around with when it comes to triangle here? Domain shader output. Domain shader output. So I pretty much define we had ID somewhere around in the hull here. Patch ID uint patch ID. We're working with triangles, so each triangle has a unique ID. Or what the hell? like the best approach to this is, or the best approach, the only approach I can find right now is that we duplicate this mesh, we do one triangle and one, but what the fuck? I want to see if it works. Doing it with points. What's up, Ashiro? I'm doing pretty good, actually. I've learned a shitload today. It's been very nice. But as usual, problem after problem. So let's add a new script here. I want to add it under... MISC, or what do we have here? Assigners, constraints, extensions, bond, structs, tools. Nah. Nice to hear. What are you trying to do right now? We're trying to do procedural grass from scratch. So we have this little plane and we have managed to generate some grass straw, and we can subdivide it as well, but Jesus, subdividing it leads to even more duplicates. That's pretty sick. I wonder why. That is definitely not good. I mean, yeah, so you get as many duplicates. So when it gets to grass straws in the middle, you get as many duplicates as the number of triangles sharing that vertex. And that's why we see some of them have 5 and so on. That sucks. But okay, so I want to try this. So let's add it to let's set it to a constraint, and I want to do change mesh. Just gonna do this pretty much. Change mesh. Jesus. Change mesh topology to point. Is that a constraint? Yeah, maybe it is. Okay, let's try it. But it's gonna happen on a wake. Ah, well, let's do it. Could I... Context menu. Oh, well. So plane 8 times 8. Let's add... Oh, yeah. Or... Change mesh topology to point. Points. Okay, so when we start, this one should change its mesh topology to point. This won't... Let's see if we get some change. Okay, it gets removed. And the reason for that is probably... because... we do triangle here, but point 1. What did I use? Post dot YXZ. Okay, so point doesn't work. Like, or am I missing something? Point, triangle stream. I want to know if this would have worked if we didn't have tessellation. Okay, can I test this quickly? Geometry domain shader output. Vertex shader output. Ooh, domain shader output. Pretty much the same. Okay, there we go. And now we have it as points. But I can't select it. Okay, here we have it. And I think it works. So... And now it's just per point. And I'm pretty sure... let's see. Transform... Copy component. Let's add another plane, 8x8. Paste component values. Okay, here we have it. Yeah, okay, so this works. So points do work. Unfortunately, points doesn't seem to work with the current setup of the tessellation. But that is... I wonder if tessellation by point... Let's see how to design domain shader. Oh, come on. Let's go to tessellation. Domain attribute. Yeah, X is either tree, quad, or isoline, so we can't work with points here, which means that we can either choose this solution, so one grass straw and only one grass straw per vertex, but then, like, we change the mesh topology to be point, and we can't render the underneath mesh, which we should be able to do with the original one. So if I would choose to rely on this one, it's hard since we can't do tessellation, which sucks. But okay. So could I use ID here to check? Or is it possible to change the mesh topology in the geometry shader, like, or between the domain shader and the geometry shader? Define the domain attribute. I know it's possible now at least, but it's probably not the approach I want to take. Is this seriously the only... use domain point on mesh. Geometry. Yeah, I don't want to do this, I don't think. I'm filling a compute buffer with the vertex position of my mesh and use graphics draw procedural to put points to path. Okay. I'm extremely interested in what actually happens below the surface in this case. So does this changing the mesh topology, like when the CPU sends the data to the GPU, does it send this mesh topology setting? So like, here's a mesh, render it as triangles. Here's a mesh, render it as points. I don't know why it would work like that. Like, shouldn't the GPU be able to switch between the two? Like, okay, the CPU needs to tell the GPU, but the GPU should be able to switch between them, shouldn't it? Like, It should be able to switch from mesh topology triangle to mesh topology points, but not the other way around, right? Because it's a decimation. You need less information to render mesh topology points. You need more information for triangles because you need to know which points belong to a triangle and so on. It should be possible. Okay. Two 2016. Topology of mesh faces. Normally meshes are composed. Unity change mesh topology in shader. Geometry shaders have an input and an output type, and they don't have to match if your mesh is using a line topology. Okay, that's true. So in the geometry shader here, except for generating a new triangle, I would also like to append like the original triangle. Because I want the ground as well. And that's easily doable, but it's not if we have it as point here. So like instead of relying on setting the mesh topology and such in script, I would really like to work with triangles in here. I think that's is better in every possible way, except for the fact that we currently miss some of the vertices, and two, we draw duplicated billboards. or duplicated blades of grass. So if we do tessellation, could I pack information in the tessellation, like don't generate grass for this vertex and so on? Probably one way to do it. This is gonna be an interesting problem to solve, if it's even possible. We have geometry shader. I want to see, do we have some more? What's up, Rod Dev? How are you doing? Okay. Ooh. Pretty cool, actually. So fucking weird. Domain shader output, domain triangles. So this one needs to be the same as this one. And here we only had lines, triangles and quads, I think, to choose from, so no points. This sucks. Let's see here. Could we do something with clockwise direction and stuff like that? So this one goes this way, but actually the other one does as well, right? Yeah, but have pretty full control of what information we can pack. So maybe the correct thing to do is, so here we work with vertices in the vertex shader. Here we work with triangles in the hull, and here we have something ID, which I've mentioned before, output control point ID. What can we do with this? And like if ID is patch based, one input specifies a variable containing a patch ID. So ID per patch, so we get a different ID per patch, so per triangle. Can we create a Boolean value? So if we try to set like what this tells me, it seems like don't you get a lot of, like, doesn't the values of a vertex change multiple times? So like if you work patch wise, if you work per triangle, and so if we take for instance hull shader control point output, still have high hopes for this one, but I don't think it will help that much. But to me it feels like when you do this subdivision and stuff, do you set the same values multiple times? I think probably not. Wait. What the fuck am I? Drunk? Why don't we just calculate the medium position, pretty much? Like, if we have 3 vertices, why spawn them at every vertex? Why not just... We have these 3, calculate the middle, spawn it there. We have these 3, calculate the middle, spawn it there. What the fuck? Right? Have I seriously been thinking about this for like 1 hour without seeing this, or is this wrong? Oh, this is nostalgic. I just want to get the barycentric coordinate of this one. So, what is it? 0. So a third should be easy. Let's calculate pos as, what the fuck? Or am I extremely tired now? Like, is this completely wrong? What the hell? position. Oh, Oh, why am I not getting a result here? There we go. Okay. Why? Does this result in less grass, straws? But this, like, this should be it, right? We don't get any weird pattern from this. Okay, great. Like, Jesus. That this... I'm gonna check this into more, like, check this out more tomorrow. But like, this should probably be the solution. It's just a little bit weird that it took me this long to arrive at it, but hey, sometimes you're not feeling it. But yeah, very good progress today. I've learned a lot, to say the least. Gonna continue this grass shader project tomorrow, probably for the rest of the week actually, and I have high hopes for it, how it will turn out in the end. Is this really the solution? Should have understood this. So instead of placing it here, we place it there. Oh, we're still getting duplications though. Yeah, unfortunately I don't have more time to explore this today, so that will be the first task tomorrow. See if this is actually the solution or not. So yeah, I'm gonna have to cut it there. Thank you so much for watching, everybody, and hopefully I will see you tomorrow again, and have a great rest of the day. I wouldn't call myself a wizard, but I appreciate it. Bye bye.